or someone in the room?
Mic line, mic test.
Could you hear Mike in the
mic test?
Could you guys hear Mike on the speaker from the room
Hello?
or MCR?
Yes,
Yes, yes.
We got double mics. Okay, so somebody who wanted JavaScribe in the room, just monitor the monitor the comments on the list, and if somebody needs to have mic time. All right, double duty for Mike O. Thanks. All right, so let's get started. Thanks for joining us. This is the RATS working group. This session is being recorded. It's Zulip. It's just monitor the activity on the chat, and if someone needs to get to the mic, be their mic person for them. Raise your hand, and whatever. So here's the note. Well, basically, these are the rules for contributing to IETF meetings. If you're not familiar, please familiarize yourself before you make a contribution. Just as a reminder, the IETF has a code of conduct, and the basic idea is to respect everyone. So as far as thanks everybody. We got our volunteers, and here's our agenda. So we'll do an agenda bash. Is there anything that we need to talk about that's not on the agenda? Okay, we do have a little bit of time left at the end, so we'll see if that gets used up from going over. So first up then is Eat Media Types. This is Thomas's Fasadi is going to present that.
Hello. Hi, Dial. Can you hear me?
How are you?
Yes, fine, thank you.
By sharing.
I don't see the slides, Ned.
Okay, how's that?
Yeah, I can see them. Thank you. Okay, so this is for Eat Media Types. Next, please. Next, please. Okay, next. Sorry. Quick recap. So we have 6 new media types defined, one for each of the production of the EAT grammar. So JOT, CWT, and then the bundles and UCCS for both JSON and CBOR. Next, please. We also have a new structure syntax suffix plus CWT that indicates that the media type is encoded as CWT. And this is similar to, well, equivalent to JOT plus JOT defined in 84.17. Next, please. Recap of the working group. Let's call. Next. There was no on-list feedback, and that was somewhat expected given the fact that the document is super boring. We have an issue open on the repo is issue 17 from Jiri. Wants to have a discussion on when it might be appropriate to not to use the media types that are defined in this document. He proposed some text in PR 18. There has been some comments from myself and Lawrence, but please chime in, the more the merrier, so that we can conclude that discussion. We also had the Shepherd's Review, so thank you, Kathleen, for pointing out the fact that we had some stale text in the document that we cleaned up now. So next, please. After we've concluded discussion on Jiri's issue, we are ready to publish 06, and I think that would be the final version of this draft before we send it to the area director and ISG next. In what we wanted to have is an early allocation for these media types, because at this point in time we are blocking other documents. For example, the PSA draft is blocked on EAT plus COT media type, and that would unblock them. Next, please. So I wanted to summarize the early allocation questionnaire from the RFC. We seem to be green on the 3 bullets, right? So the fact that the code points have are from a space designated as RFC required, IETF review or standard action. In fact, it's under the application. All 6 are under the application. So the standard 3, the format, semantics and processing and other rules related to handling the protocol entities defined by the code points must be adequately described in an internet draft, and this is the draft where this happens. And then that the specification of these code points are stable, and we think they are. We haven't changed them for a while. They are in use in a few places already. So what remains to do is that the working group chairs and the area director take a look at the document and make the judgment call whether there's sufficient interest in the community for early allocation. So there is implementation already, this running code that we have deployed. So I think there's the potential of not making an early allocation can lead to contention or other problems. In this case, the fact that other documents are blocked without reason on this. So that's it. I think the ball is in the end of the chairs and the AD for this.
Are there any comments?
Yes, and I have to finish the write-up, and that I'll do. I'm just waiting on IPR declarations. I think, so I'll get to that tomorrow, assuming all those IPR declarations are in. Thank you.
Thank you, Kathleen.
Mike's on the queue.
Yeah, Mike Jones, as a data point, in the W3C, the verifiable credentials spec for securing VCs using COSE has a dependency on the plus CWT structured suffix. So this is another data point that it would be great if that moved forward with due haste. Thank you.
Thank you, Mike. I didn't know that, but good to know.
Any other comments? Okay, so given that we've completed the working group last call and there doesn't appear to be any objection, I think we're safe in moving forward with this document.
Cool. Ned, so in terms of early allocation, what is your thinking?
I guess it's a question of, is it a race condition? Do we need, do we need the early allocation in conjunction with moving the document forward?
Right. Can we just do it along with the process? It'll go into IETF last call. I'll write up the Shepherd's report. We'll put it into the area director. It'll require an area director review. I mean, you're close to the end at this stage
Mhm.
if you just go through the process as opposed to getting an early request. We are in an AD transition, so, but the new one coming in is also stellar, so I think we'll be in good hands,
Okay.
even though she's getting up to speed. She's a longtime IETFer.
Okay. So what I'm hearing is that there is not going to be early allocation because the working group chair think that progressing the document through the normal route will give us the code points in time early, let's say, or at the same time we would get them from by requesting an early allocation. Is it correct?
I think so, and I can work with Deb too, so I'll
Okay.
help her out.
Okay.
If we
Thanks
think
very
it'll
much.
take too long, then, we can work for the early allocation. Hi, Roman.
Lawrence is on the queue.
Yeah. Hello. So,
Hi, Lawrence.
hi. There's a normative dependency on UCCS here, I think, and there was a pretty large set of comments to deal with that. So I just wonder if you get stuck behind UCCS, if you're concerned about that.
Good point.
Thanks.
Hi, Roman Giannetti, responsible AD. To build on what Kathleen said, what Lauren said, I think the question I would have is how quickly do you want the code point? Is it measured in, do you need it in weeks, or is it okay if it's a month or two? And that kind of directly influences whether you ask for early allocation. It's a little bit unusual to ask for early allocation at the same time you send it to IETF last call, because it's
Right.
going to happen pretty soon, kind of regardless. It's really kind of a question like what's driving it and how long can you wait?
Okay, so the point raised by Lawrence about blocking on UCS doesn't prevent us doing the allocation, right? So progressing through this document through the process and getting the allocations, is it? Because that's the main point, right? We don't want to be stuck behind anything and just have the normal progress. So that we can have, as you say, a couple of months, 3 months time, the IANA tables filled with this.
Yeah, I think we can most definitely get it much sooner than that.
Okay, that's great, fantastic. Thank you.
Okay, next topic is conceptual message wrappers.
Okay, thank you. Sorry, I probably messed up the thing because these are not the slides that I wanted to go through. But anyway, it doesn't matter. Next, please. So we went through the first working group last call, and we concluded that we have we're building some relations with other documents in the ATF, and we'll look through the next step that we co-editors, we think we'll put forward. Next, please. So we had this working group last call recently. We had excellent feedback from lots of people. Thank you all. And this resulted in major improvements, both on the editorial side and content-wise. Next, please. Okay, so on the collections, we made some big changes. The first one is that we unified CNW type and value and the collection. So the collections are now part of because they got into the top level CNW production, so they are treated the same as a normal CNW. And the other thing about collections is that we allow now mixed encodings. Before, we only allowed homogeneous collections where you could only have, a JSON object within a JSON collection or CW CBOR objects within a CBOR collection. We now have a tunneling construct that that allows us to move CNWs of one type, say JSON or CBOR, into collection of the other type, say CBOR or JSON. Next, please. And this has some repercussions. one being the fact that the PCAC extensions that we require now applies to both type and value CMWs and the collections as well. And for this, we had to clarify the relationship with the OID that is defined by TCG, which has slightly overlapping semantics. So I think we have clarified that in a subsection, but to be checked. And we also have a new reserved label in the collection that was added to type the collection, to create a type for the collection in a unique way. And this can be used as a parameter for the application CMW's CMW media types. So both JSON and CBOR have now a media type parameter for specifying the type. Next, please. On the editorial front, we had some refactoring on the CDDL to improve readability, hopefully. Ned went through the whole document to replace array with record to resolve some of the ambiguity there. And thanks to Lawrence for pointing it out, we added more examples. And one especially regarding the use of the CMW claim, so that you can stash CMW or CMW collections within EATS. Next, please.
You have a couple of people in the queue. Do you want to hold that off until the end or do it now?
Yeah. Oh, no, is good.
Okay, Mike.
The first bullet here, Mike Elmsworth. The first bullet here, is that a reference to the CSR attestation draft, or is that something I don't know about?
No, it's something that we define. Now, if you want to use it in the CSR draft, then that's great. But it's not something that we get from the CSR draft.
The PKIX, yeah, I'm trying to figure out what the PKIX extension is. I'll go read your draft. Thanks.
Okay.
See, I maintain the registry for the OIDs for TCG. No, I'm sorry, Monty Wiseman. Thank you. Hey, thank you, Monty Wiseman. I'll be happy to work with you if you need any clarification on that.
So TCG has defined an OID to carry CMWs in a PCAX object, right? Be it a certificate or a CSR or a CRL. We do the same, but this has extended semantics because it also covers the collections.
So I guess my point is, I'm not sure what the question is from this bullet. I'm just telling you, you can work with me and I can help you with the sub bullet, clarify relationship to TCG OID semantics. I'm just offering to help with that.
Thanks very much, Monty. So yes, and the help that you can give us nearly immediately is, well, I can, well, no, because it's in the editor copy, but I will share with you the editor copy and so that we can work on that. We have a subsection that, is meant to clarify exactly what the overlap is and when one could use our OID or the TCG OID. But yes, I think I will share this with you to get some, to get it, ironed out and sure that we agree. That's great. Thank you. Awesome.
There's some comments online saying, please, eat the mic when you're standing at the mic.
Okay, next, please. This we went through already. Yeah, so relations with other draft, I wanted to highlight the fact that we have other draft that somewhat consume this format. And one of them is the CSR attestation that Mike was mentioning before. But there are others. There's the TLS attestation that also does that. And there's another one, which is the draft CAT, the key attestation token based on it that we, it's a personal draft, but it's something that we would like to push forward and depends on this format too.
Mike's in the queue.
Mike Elmsworth. At the risk of slowing down the CSR attestation draft, do we want to add an example to the CSR attestation draft? Like an actual encoded CSR showing how this fits in?
I've spoken to Ras about this, and I've given him some pointers in terms of running code that we have that he could use. And he said, as soon as I have the code point, I can produce examples. So I think, yeah, that's entirely possible. And I think you already have Ras on the case. So I don't want to step in and make a mess, but I can help certainly if you need it.
Okay, perfect. Yeah, because you're defining an extension, so
yeah.
I was about to say, yeah. So if we decide to we want the CSR draft out super fast, so we might need early allocation of your OID if we want to put it in as an example.
Okay, that's interesting. Cool, good data point. Thank you.
Or you could use the TCG OID.
It depends on what you want to stash in. If you want to stash a collection, no, you can't. But otherwise, yes.
Sorry, Mike Ellsworth again. Although the registry you'd want to allocate that OID in is defined in this, is created by the CSR attest draft. So there is a circular relationship there.
Okay.
Yeah.
Right.
Yeah. There were some sidebar comments saying that the CSR draft could allocate the OID, and then this draft can use it.
Okay. Let's talk about this, please. I don't think we're talking about the same OID, but yeah, let's clear up the confusion because it's important. Okay, next, please. So next steps, we have some issues to resolve still on the editorial front, and once we're done with those, I think we can publish 05 and maybe call a second working group. Let's call because we think that the draft is in pretty good shape now, and we are ready to progress this. So yeah, that's our next steps. So basically work after the meeting to close these issues and publish the thing that is ready for another working group. Let's go. Don't know what the chairs think about this, but this is what we wanted to do.
Yeah, so have you submitted draft version 5 yet,
Not
Tom?
yet. Not
Yeah,
yet, Nancy.
so-
We
When you do, just let
Mhm.
us know. We can start a second one.
Awesome. Thank you.
And it would be great to hear from those that provided feedback, whether your comments were resolved satisfactorily.
Absolutely. Yes.
Yeah.
That would be great. Thanks. I think that's it.
Okay, so next up is
Corin?
Coram. Find it.
Hello everyone, can you hear me?
Yep.
Hi. So good morning. I'm going to quickly skim through the work done since last IETF, between last IETF and day 5 IETF. I have approximately 5 minutes, but I think Thomas has given me some leeway there by presenting rather rapidly. So yeah, and I will do my best. Next slide, please. So the agenda is roughly split into these 4 key bullets. First is a quick status update and progress since the last IETF in terms of GitHub. And then in terms of actual content, we are going to run through the 3 stuff, which is general tidy up, few enhancements which we have done, and simplifying the verifier algorithms. There is some work under progress. So Ned is going to talk about the last bullet. So yeah, next slide, please. So I wanted to highlight that there's still a high number of GitHub issues, but most of them are kind of a bit similar type of issues have grown up. While I was just scanning the issues, I found that a lot of duplication has happened. We are going to tone this down, but broadly there are stuff which we need to immediately finish before we can go for working group last call. Is there pending issues which are further classified down into asking for CBOR tags and registry related issues, and then there are some text related clarifying certain actual content of the Corium draft, and then the verifier algorithm improvement needs. When we are trying to simplify, they created a lot of issues which we need to effectively work upon. And on the right is enhancements which can be kind of done for the future releases, which are broadly the number looks high because a lot of duplicate issues are there, but mostly like similarity, mostly issues like cost feed examples, how to document cost feed examples, and extensible rim freshness, and those kind of advanced features are there as part of the enhancements. So, next slide, please. So these are certain. This is some tidy up of the language we have done in the spec, which is like we have tightened the usage of profiles, how profiles should be exercised, and then we have kind of become more crisp on the use of extensibility, where extensibility only vendor defined extensions always has to have negative code points, and the positive extension should be registered with IANA. So that has been tightened and added more clarity on the key terms used, like claims, accepted claim set, etc. in the spec. Yeah. Next slide, please. So now I'm going to take a little bit time on explaining the various enhancements which went into this release. So in the identifier section, we have added tagged bytes as a new identifier type, which is very relevant to certain use cases. Basically, it adds a tagged byte, a variable length identity introduced in the spec for identifying any class instance of group variables. This instance, for example, this instance identity is required for modeling ARM CCA realm instance realm identity, and also for AMD SEV scheme. A chip identifier is using this, so making it is part of base specification helps other implementers to just use that without defining them in the profile. And then another concept we have introduced is the concept of integrity registers as one of the measurement values. Basically, it helps anybody who wishes to model one measurement environment to have multiple measurement objects, with each measurement object having a set of digest. That kind of concept, to absorb that kind of concept and to model that kind of concept, we have defined these integrity registers. The first class use of that, or the most obvious use of that, is modeling the TPM PCRs, where each PCR identity is the measurement object which is uniquely identified by an integer identity in case of TPM PCR, or it could be a workload measurement pertaining to an environment. So that relevant thing has been found to be very useful. So it's part of the base specification now. Yeah, next slide, please. And the last, we have added a new triple, which is much more, I would say, polished triple, which lets you match reference value from multiple environments or sub environments for a given and then associate a certain endorsement value to a target environment. So it's a bit hard to explain, but I will try to give. That's why I have listed a use case example how one would utilize that. Let's say a composite attester or an attester is granted a security certification only when it is known that it has a collection of elements or collection of software components, each running a specific revision. So certification or security certification applies when a particular software component matches a particular measurement, and you can have a collection of these to grant a security certification. Or an equivalently, a composite attester which achieves a certain benchmark when a given combination of sub-attesters or target environments runs a specific revision and configuration. So the name of that advanced triple is, next slide please. The name of that triple is called multi-environment conditional MEC endorsement triple. Each triples describes a series of endorsements are applicable to a collection when it's based on acceptance of a series of stateful environment records. That's the thing. So it has, as a first entry is in the composite triple is a set of conditions, which is all target environments along with specified state needs to match the triple entries into the accepted claim set. And when that condition matches, then all the endorsements that are applicable in that triple are applied to the accepted claim set. Yeah, when the conditions match. Yeah. Next slide, please. So this is just an introduction about verifier algorithms, where we decided to introduce layers of evidence matching in verifier algorithm and just retain the base layer matching algorithm within the core spec and move the more advanced stages of verification to the appendix. So I will let Ned take on from here to describe the verifier algorithm a bit more into detail for simplification. Yeah, thank you.
Okay, so not as chair. So just to recap what we'd already know about verifier inputs based on the RATS architecture. Essentially, there's three types of inputs: the evidence, which is a set of claims that come from the attester. The idea is the verifier will accept the evidence if it's authenticated to the attester. That's kind of the assumption that we're making from a verifier's perspective as to why would it accept evidence. Reference values are a set of claims that come from the RVP. The verifier accepts the reference value claims with the expectation that they will match evidence. And then endorsements, a set of claims from the endorser. The verifier accepts the endorsement claims with the expectation that the attester is valid. In other words, the endorsements are applicable if they apply to the attester in question. So verifier inputs actually have a matching condition. This is maybe a new concept than what has been discussed in the RATS architecture, but I'm going to work through some examples here. So if in an endorsement example, the attester has, take the case where the attester has a digest value, call it X, and there's a CVE endorsement claim that should apply to X if that digest X is known. So what we're saying here is the matching condition is that the CVE applies to a digest value X, and if that value is true, in other words, it's a representation of the state of the attester, then the endorsement claim, which is in this case a CVE, would apply to that attester. Another example for reference values: if the reference value claims match evidence, then the attester is valid. That is to say, if the attester has evidence, a set of evidence claims, and the reference value provider has a set of reference claims and they're equal, then they match. Okay, so in essence, the evidence claims are the condition upon which we accept the reference value claims. And the only difference here is that the entity that's asserting them. And then an evidence example, it's really, if the evidence was signed by the attester, then it's okay to accept it. So it's simply saying that the verifier knows which attester it's appraising. So it's a little more of a subtle kind of condition, but you can kind of lump it in there if you like. So I see Mohammed on the queue.
Hello, do you hear me?
Yep.
Okay. So by doing this matching condition, don't you think that you are actually limiting it to be an equality or such kind of thing? I mean, it could be broader than that. It could be something that you do not want to match, something that you might want to block, or something that you want not to match. So what exactly is the reason behind doing this kind of limitation to matching condition?
So I think in the case of reference values, it's not trying to assert that they have that it's an exact match scenario. A reference value could describe a variety of states, but the evidence should be, within that superset of states. Otherwise, the matching condition is basically if you have a set of claims that are not pertinent to the attestor's state, then it kind of doesn't make sense to try to match on state that's not relevant. So, next in the queue.
Can you hear me?
Yeah.
Hi, Ned. Thanks. Regarding the endorsement example, beyond me not being a CVE enthusiast, haha, are we asserting that that the system under scope of test by it does not have a CVE as the attester is claiming it? Am I understanding correctly?
I mean, this is just a random example. The idea is the CVE is one type of endorsement claim. There could be lots. Okay. And so it's just saying that the CVE endorsement applies if there's a digest value for some software against which the CVE applies.
All right. And this is where freshness comes in, because I presume you can only assert that you attest that it doesn't have that for a certain snapshot in time, and there's some other context that's be known about whether you can trust that attestation or not.
Yeah, you're touching on some information that's actually in another draft, which is called the endorsements draft, and it talks a bit about actual state and possible state, and so endorsements are intended to apply to some actual state of the attester.
All right, I guess that gives me what I need to know. Thank you.
Okay, let me maybe keep going, and maybe it'll make more sense when we get into it. All right, so one of the things that we found helpful in working with the structure in COMID is there's a structure called a triple. There's actually multiple triple records defined in the document, but what we observe is there's an abstract representation of it, which fits this model, which is every triple essentially has these four components: the conceptual message type, the condition, the claims, and the authority that's asserting the claims. And so conceptual messages are the things you might expect: evidence, reference values, endorsements, and so forth. Conditions, we just talked about it. Claims are the new claims that about the attester given the match condition is satisfied. And then the authority is typically it's a key, but it's some representation for who's asserting the claims. And we necessarily want to keep track of that information. Hank, you're on the queue.
So hi, this is Hank. At the top of the slide, so I should eat the mic, I heard. Okay, at the top of the mic of the slide, there is this term triples. So triples is owned by knowledge graphs, which typically means subject, predicate, object. And with these building blocks, you model knowledge based on terminology and relationships and such. And so that's semantics. We borrowed this term here. We qualify it with commit triple, and we cannot compose complex graphs with it like an ontology could do. We nest those. We nest them in trees. And that is a constraint on the use of this triple concept. There are also other technologies out there that want to express supply chain information. And they, for example, borrow just the middle part of a triple. That's called a predicate. And we see that this happens in a lot of places. So I think the concept here of borrowing from the triple concept is very important for us to make people understand where and how this works. But also we have to distinguish at some point. I think that is then when we are finalizing documents here to set ourselves into a relationship with these other uses of the term triple and what they are composed of. In general, I'm super in favor of it because it makes everything a lot of clearer. But at the very, very beginning, when you read it, you expect like the subject predicate object thing, and it's not exactly that. And so I think we have to go into a comparison section there that gives the state of the art and such, but that's just a comment here. I think this in general is great.
Okay, Mohammed in the queue.
Yeah, so how exactly is the appraisal results different from attestation results?
They're actually the same. Maybe that was just a wrong choice of words.
Okay, that's fine. And don't you think that you are basically like condition defined as claims and claims defined as new claims? So isn't it that you are overloading the term claims? So wouldn't it be better to define where it states in the box claims as something like derived claims? Wouldn't that make more sense?
Maybe it's just terminology, and we've defined uppercase claims, so that's kind of why I used it. Yeah, but the point of this talk is, yeah, there are some semantics that we want to try to highlight in terms of how the condition, the relationship between the condition and the claims that get asserted.
So condition is basically, isn't it supposed to be? So I'm still trying to struggle. I'm still trying to think about what exactly a condition would be. Do you have an example to?
Yeah, it's basically saying if the current state of the attester is X, then change its state to Y. And just claims represents either the current state or the new state, the projected new state.
Okay. And if that state was as desired according to the condition, the new claims will be added to that set of claims that you already have.
Yeah.
Right? Okay.
Yep.
Okay, right. Thanks.
Okay. I have Hank in the queue, or you're not in the queue? So here's an example for how to process conditions. You see on the left is a set of accepted claims or to be accepted claims. And then in the middle is the matching conditions. And this is just, a representational, explanation. And then to the far right, the actions. And the actions are simple. I'm going to append a record into the accepted claims set of records. And so to begin with, record number 0 is kind of the record that is initialized when the attester reaches out to the verifier and says, hey, I would like you to appraise me. And the verifier creates a context for the attester. Typically, it's some kind of a connection. And then the evidence condition is asserted by the attester that says, hey, I have evidence. And if you're talking to me, then accept my evidence. And so that's kind of the condition is just, hey, if it's me, here's my evidence. So that gets us to record 1. Then there's another input, which in the next case, in the next row down, is the reference value condition, which is a reference value provider is asserting an input, which is saying, hey, if this if the record 1 exists in the accepted claims, then I want you to accept my reference values. And in this case, I show it as claims 1 in both cases because they're identical. And the only difference is who's asserting it. And so in the case of record 2, the reference value provider is asserting, claims 1. And so essentially you have 2 records in the accepted claims, which is claims 1 asserted by the attester, or testing environment 1, and claims 1 asserted by the reference value provider. The next example is an endorsement case where there's endorsement claims that are to be asserted, and here the question is, what is the scope for the condition? And in this case, it's all of the existing claims that are in the accepted claim set is the scope. And if the condition is matched, then it asserts record 3. And so in this example, it matches, and so we've accepted record 3, and so forth. An endorsement condition number 2 can be asserted. Now, in this case, the search scope is modified to include record 3, and so if the condition matches anything in the prior set of records, then we assert record number 4 is added to the list. Mohammed, you have a question.
Yeah, just a clarification between claims, because here you write claims 2 and underneath you write claim set 3. So is there any distinction between claim set and claims?
Yeah, no, it's a typo.
Okay, that's fine.
Okay, so let's talk a little bit about scalability. One of the concerns we have is, how does this scale? So there's the Horn scalability clause basically describes, different possible scalability properties that you want to watch out for. And in this case, we're limiting the set of the set of records to be conjunction only, which if we do that, means we can get processing complexity, is either linear or polynomial. And so if we assert that updates to the accepted claims are appended, right, because of the position in the set doesn't really have any significance, then it's okay to just say, we're just going to add to the end of the list. In terms of condition processing efficiency, of course, you can do things to make improvements by building indices and having index search capabilities. In the case where a condition doesn't match, then you can try it again, essentially put it back on the input queue and process some other inputs, and maybe with those other inputs you'll find a situation where the condition does match. And of course, the verifier can stop accepting inputs as needed. So this is typically based on operational conditions, like there's an expectation for when the verifier needs to get back to the relying party, and so it's going to put a limit on the amount of time that it can devote to accepting new inputs. So here are some examples of what you might expect. And just a little bit on the notation, there's a pattern here, which is there's the condition, the set of claims that are to be asserted in the authority, and then that results in a new record that would be appended to the accepted claim set. So here's an example where we have a digest we have in evidence, we have a condition, which is, hey, it's, attester number 1, it's me. And it's asserting, a digest claim under its authority, key ID number 1. And given that the attester has authenticated to the verifier, then we just accept those claims straight away. So to the right is the list of, is the first record. In a reference value provider scenario, the reference value is the same digest. So in a sense, it's the condition and the claims are the same. And if they're matched, then that record is added to the claim set, but under different authority. In the case of endorsement number 1, this is asserting the claim that if the digest FED4 is in the accepted claims list, then, and it's asserted under the key under the authority of the reference value provider, then assert a security version number, SVN. In example number 2, or endorsement number 2, this is saying if the SVN is 7 and it's asserted under the authority of endorser number 1, then assert that the version is 1.0. So you can sort of see how, we're just adding more claims as you go and building a richer view of the attester. So what happens if more claims show up? So we could get more evidence, for example, in which case that's fine. We just accept it. But then we get more reference values as another condition. And in this case, the scope is essentially all of the previous evidence and the new evidence. So you can see the search scope expanding to include all the evidence records. So now we're going to talk about views, or in a way, in other words, a way to restrict the set of accepted claims that are visible or interesting. And typically this is from the perspective of the relying party. Okay. So think of a view as a subset of the accepted claims, or at least typically it is. And so a view tuple might look like what you see here in the blue text, which is the view name, the condition, the authority, and then the results based on if the condition matches. And so what happens if the condition is matched is those claims are copied into the view. Receipt of a view record can trigger processing. So think of the scenario where relying party makes a request for an attestation result. The view is part of that request, and that triggers, and that that is something that could trigger this processing of the view. If the verifier still processes inputs on the view result, one thing to note here is if the verifier is processing inputs and the view results differ, that if the requester is making multiple requests and the verifier is still processing inputs while each of those requests are being made, then it's possible for the results for the different requests to differ. So it's important to be able to know when for the verifier to stop processing inputs. And another kind of a note here is the verifier itself could append its own claims. So think, for example, error for SI. This would be a set of claims that the verifier asserts it adds to the accepted claim set based on an appraisal. Hank is on the queue. Do you want to go back?
So this is Hank. I want to start with views are not for everyone. So a simple relying party expecting a simple attestation result that is passing by, trying to do a secure interaction with the service might not be interested in a view. View is an optional concept that I think would require a relying party to be pretty powerful. It has to have an opinion about what it wants to see. And also maybe has to wait to get the result. So there are different scenarios here where attestation results are just presented and you're happy with them or not, or you can have the view concept and I think more complex setups. I think it's a scalability thing. So I just wanted to point out that not every relying party must have an opinion about a view, and a whole REDS domain that is set up does not necessarily have to support a concept, but it's really useful if you want to, if you're like with confidentiality or PII or other permanently setting up, like more static setups, I guess. That's very important to highlight here. A passing by cell phone might not have a requirement on this.
So here's an example of how a view might work based on the accepted claim set that we've seen already. Here we have a query consisting of two conditions. Condition one is trying to match against assertions that have been made by reference value provider one. And condition two is asserting that it wants to know about any claims that have been asserted by endorser number two. And so you can see that matches two cases. And so both of those records are copied over. And what you might expect to see then is something that looks like this, where you have the view is the, the view name is, whatever the requesters wanted it to be, my view. The authority is under the authority of the requester, in this case, the relying party number one. The condition is essentially saying it's an or condition that's saying if the asserter is the authority of RVP1 or the authority of endorser 2, then accept their claims. And so the records copied would be these, a reference value and an endorsed value record, as you see there. So that's basically it for the presentation. Hey, Hank, are you in the queue? Okay. Mohammed's in the queue.
Yeah, a quick question about slide 6. You were mentioning the Horn scalability clause, and I wonder if it's a typo or something because I haven't ever heard about this phrase.
You're talking about the Horn scalability clause?
Yes.
This is referring to ways to measure complexity, and so if you look at some of the Horn clauses, they have to do with how conjunction or disjunction are processed and what the scalability properties are for the different types of conjunction disjunction operations. And the simple case, we're simplifying this to say we don't think it makes sense to have claims that are saying that are negations. In other words, we don't think it makes sense to say that an attester can have the claim of digest X, but also is not digest X. Right? We wouldn't allow both of those claims. And you could get into weird scenarios where if one entity is asserting that digest X is part of the state of the attester, and some other entity is asserting that not digest X is part of the state, then you have contradictory statements. So just
okay, right. So
that's quite a bit.
So basically, it's a scalability of Horn clauses, right? So this is what you mean to say.
Yeah.
And do you have the formalization in Horn clauses? Is it already in plan, something done, or is it?
No, we're basically saying, hey, we're not allowing any negative, no disjunction, right?
Okay.
No
okay.
negation. Yeah.
Right. Thanks.
Okay, and that's it.
I'll let you run 5 minutes over since we have time at the end.
Okay, thanks. So putting the chair hat back on, we'll move to the next topic, which is next set of RATS problems. Hank.
Hi, this is Henk. The title slightly changed from the agenda. So this is rats all the way down. We borrow that from Michael's slide where the turtles are stacked with the roots of trusts. And this is not about an ID. There's no IDs associated with this slide deck. It's basically a rendering of napkin nodes that we aggregated when talking to other interest groups from the supply chain. So for example, there are people creating S-bombs out there and they want their artifacts and their S-bombs to be trustworthy. There are people out there that have supply chains that create a lot of endorsements about their hardware. That is a commodity produced with the same quality as the product itself. And they want to have some trustworthiness associated with those endorsements of their components. All these are value add graphs, typically known here as supply chains. And there are a lot of people here that we talk to. So going to the first content slide, I think we all know, next slide. Do I have a clicker? Should I be clicking?
You can try it.
Okay.
Or you can just say beep.
Okay, whatever. So I'm not doing this. Okay. So our starting point is RFC 9334. That's the RATS architecture, and in that architecture, that's called RATS, the Remote Attestation Procedures. RATS in general are not solitary creatures. In our case, they're nested, interconnected, or layered. We will come to that in the context of the slide content. And currently, the vast majority of the RATS work is focusing on a single RATS domain. There are a set of verifiers, there are testers, and they have a certain task that is captured by the figure 1 in the architecture. So figure 1, I want to call a single RAT. And in practice, there are various RATs involved. That's why we have this Venn diagram representing a RATS king. That's basically all the tails are tied together. And this presentation is about how these RATs. You have a t-shirt of that. Not yet. I forgot to attribute this. This is recorded. This is created by Stable Diffusion. It is not me. I can also post the prompt on list. So next slide, please. So this is figure 1. We're starting here because that's a rat. And now we want to paint that rat a little bit to make it more understandable in the next slide. So next slide, please. So we're coloring this. So our rat in general is green, and our rat has some interfaces. These are blue. We are using abbreviations here, like small acronyms, so it makes it more readable sooner. You will see why. So now we'll arrange this diagram a little bit on the next slide. And we're focusing on 3 connection points. At the very input of this rat, there's either the endorsement when you kickstart everything, or there's evidence, as we just saw all the time. And then from above, where the verifier owner lives, you get appraiser policies. So the verifier to the V in the middle. We also have RVPs, but for the example and the exercise we're doing here, we're not making this too complicated. Just ignore this. There's a tester there, and this attester here, and this will go to example 1, is doing something. It has a workload build environment. Workload build environment and such is an interesting topic here at the IETF right now, because we have a new working group working about that. So I think that's a good example. There's artifacts here, and there are attestation results about how that all worked out. We call these claims, therefore, one time in the slide, supply chain claims, because I think that's very appropriate. So we have this remodeled figure 1. It's already a little bit biased towards a certain use case. So next slide, please. And that's even more simpler. So we have this molecule, this particle here, right? This is a rat still, but this rat has interfaces. And now we want to connect them as the Venn diagram showed at the very start. So next slide, please. That's pretty straightforward. So what we can learn here is somehow the attestation result of one rat could become evidence to the next rat. And there are other claims, as we heard already by Ned's verifier behavior presentation. There can be other claims added by the verifier, and they can, if the attestation result receiver, that's a relying party, also becomes an attester, there can be other evidence claims added to it. So in general, next slide, please. There's this composite of attestation result and evidence in the middle, and these blue boxes are, I think, the thing that we have to talk about how to use them in the future. So next slide, please. This is an example that was already somehow hinted at the first bigger colored red. This is now a concatenated environment situation. We thought that GitHub environments that are chained are a typical way to build software. There's a dependency tree in there. And so, one CI environment consumes the output of another CI environment, and each of them is their own rat. So they can be deemed trustworthy. At the very end, that's a little bit open here, you get a software product. You build something that is actually a package that can run somewhere, be installable and a nugget, whatever. So what we add here as exemplary claims, for example, is an SBOM that is created by the attester. That is obviously a build environment for something that has been built. Creating SBOMs is a cool thing that people want to do today. And you basically also create the artifact. All of this can be done now in the scope of one rat. And therefore, we augment it with all the attestation results that we produce today. I also have this CVM acronym here at the bottom that I'm not expanding. That's a confidential VM. An attestation result, of course, as we all know by A4Z, can include confidentiality-related claims. So this is one way to chain these rats. And I think that's a good example because it now connects with other work out there. There is, for example, on GitHub, a relatively easy remote signing service thing called Sigstore. They have semantics. They're called in total attestations. There were discussions about that on the list. And we were thinking about how can we consolidate all this? So the blue boxes on top, these have to have dials and some leverage to tell you what is going in there. And the predicates of in total and the triples of quorum kind of the input that is going down from the top. And then you could also ask yourself, all the verifiers, the V's in these rats, are they the same? Am I going always to the same verifier? Are there different authorities? These are also knobs and dials that you have to configure and have to set up in order to make this simple graph, it's just a chain, work. Typically, they are more complicated than just a chain. So that's basically what our direction of work is right now. So we're talking with a lot of people, not only here in the IETF, and we want to find common ground so that the RATS concept, that is, of course, somehow already pretty good aligned with the TCG concept of remote attestation, works with other emerging and real-life open source projects right now. And I have a queue, and that's fine. Because the next page will go into a transition to another speaker, so perfect timing.
Hi, this is Peter. I just have a quick question. So here, like we see, you have chained, attesting, steps. So what, from my understanding, like this is for the functionality of just the fifth components, or you want some kind of synergy of the whole chain that if that's the case, like what are the use case that was in a specific layer? It's like when you're in a Kubernetes or a container way, it's more like a whimsy way. When you're using maybe like GitHub, it's like an action, GitHub action. Maybe it's like in an IP layer, that's like a network path. But just I would like to know, like, it's for only the last components functionality, or it's all as a whole?
That's a good question. That it comes a little bit back to the view option. It really depends on the relying party on the end. in this scenario. So I would say in the default behavior, everything is like, there's a substrate, everything is frosted on top, as concise as possible, so that the end artifact or the output of this chain has all vital information to assess the dependency graph in this case. If you have a network path, I think this is NASA what you're talking about, you would have hops here that could frost on information hop by hop, and that could be trustworthy with respect for the, what was it? My memory made it. Proof of transit, for example. Exactly. So, so yeah, there are multiple ways to apply this, and this is just a very prominent example because of the correlated working groups here that are now already skilled and whimsy and such. And now I want to give Michael the mic.
I don't know if this is the right time to ask you to go back a couple slides. Pardon?
Who are you?
Oh, I'm Michael Richardson. Another one. Back to the big, the one with the supply chain things on both sides.
Mm-hmm.
That's
That
actually
one.
that one.
Yeah.
Yes, this one. So I didn't understand why they're on both the left and the right here. I think it's because you're feeding through. So I think you may. I'll state my assumption. You could tell me how I'm wrong. That will be better than the question. I think that the supply chain claims on the left are not the same as the supply chain claims on the right of this diagram.
Correct.
So that's because we're feeding through that path that
you could
on.
pass them through.
So
you can
so
make
that's
them
really,
as big as you want, but yeah. And
so that's really
because-
supply chain claims for part A, goes into part B. This is part B, and then this is supply chain results for part A, which become claims for inputs to the other side.
Exactly.
Okay.
Yeah.
If you do this diagram again, which I hope you will, maybe you'll put an A or B or something.
Yeah, there has to be numbering. Again, this unfortunately were napkin notes a week ago, and so we tried our best to make this readable. Yeah. But thank you for the question. That is absolutely correct. It don't have to be the same. Typically, they aren't. Yeah. So these are two little atoms. No, it's fine. Go to the middle of it. Next slide, please. So these are two of these blue boxes that I was talking about. That there's some knobs and dials here that we configure and express what's in there actually. So we have examples for that we are already doing that, but in an unstructured way, or only when the demand comes up ad hoc in a certain context. So we have R4Z. In R4Z, we have the attestation result augmented evidence. That is we do because when you have a really fast passing by relying party, you can't wait on the whole rat to do the appraisal procedure. This can take a while. So what we do here in R4Z, we have call it a sub-zero trust, and we pre-cache an attestation result and create a very, very small evidence according to it to show that it's still fresh. If that it is not true, so that the attestation result actually is not fresh, you can show that to the relying party. It can make a decision, a small one, like, okay, it's like outdated for 3 seconds, good enough for me, or no, I'm not talking to you because you really need exactly fresh proven evidence. And that is, sorry, attestation result, you can't give that to me. So this already, this bundling, as we saw when we combine two rats with one interface, with one blue box, that's already there. And then we have another example from the message wrapper thing where we can tag the messages in there. And if we have a bundle that tags them, we can already bundle an AR and an evidence. So we have solutions in place, and there's a reason for that, because people do not just use one rat in practice. And we haven't specified anything how to do that yet. So all these examples I'm bringing up here are basically a motivation factor for the next steps, but we want to work on out, is how to define and specify and profile the blue boxes between the rats that are now layered and nested. So there are 2 other people in the queue that I would like to give the chance to speak.
I guess that means me to start. Hi, Hank. To invoke the to invoke the famous words of a former colleague, you'll never know. I don't like it. I love it. But you said this isn't pertaining to an ID, so maybe you're going to cover this later. If this is a call for people to experiment and solidify ways of approaching this outside of just specification, where are those things going to occur? Are they already occurring? Or you can tell me to wait till the end. That's it.
Okay, thanks. Yeah, the examples, we have precedents of this being already standardized and used somewhere, and is hiding in plain sight. And that is example 2. And I want to go to my co-presenter to do example 2. And that is Ned.
You have another person in the queue, though.
Oh, there's another person. I only see AJ. If he would lower as, oh yeah, Frank. Sorry, not Frank.
Hi, Hank. Hi, everyone. This is Liu Xiang. So first of all, I'd like to thank Hank for your presentation. I think it's a very good point of view to consider the RADS working group work and on the next step. So I just have a simple question. As you know, just like you mentioned in the very beginning, in practice, we have to consider multiple RADs, which is nested to form a RAD community, right? So, but in this diagram, I can see only a chain of RADs, not a nest, not a network, or not a nest of RADs.
Yeah.
So I think maybe a very simple suggestion is that we should reconsider this diagram to, you know, for example, the layer 1 may include multiple layer 0 entities, not only one. So it's like a, you know, a sequential, a chain of trust, but not a net of trust, I think. So I think in practice, the net of trust scenarios we need to really consider.
Yeah, if you go back 2 slides, please. Again, for simplification, the acyclic directed graph that I chose is a chain. So to make it less confusing. But of course, now to provide simple nesting, the output of the red, of the most right blue, could be an artifact that is a running environment for a next chain. So all this chain here could be the input to the first red in the next chain, and the second dot in the, so you can basically nest this like a tree, and that's the simplest nesting that I can think of. And you can already have diversions that as a different path that are hopefully acyclic in this chain. And if there are cycles, I don't know how to solve that. I hope you have a termination mechanism somehow. But in theory, it's possible to wait for something that at some point becomes trustworthy and then you move on. So that would be a cycle. So yeah, I think all these options to compose them are there, but we haven't pictured them.
Okay, I got it.
Sure. Okay.
So Hank, you're running a little over, but we have time. So
Okay.
the question is, it sounds like there's more discussion as to what you want to do with this.
What we want to do is to the first question to the room and the working group in general later on the list is anything here like shockingly wrong to you? Do you think this is a wrong approach? Because we want to kind of compartmentalize the things we want to profile, so to speak. And it's less the green one. We are focusing on the blue ones. We want to define what's in the blue boxes. And then maybe in a second step, find out when we profile that, how does it affect configuration of the green boxes, and we can't avoid that. But our working thesis at the moment is that the green box are relatively stable red compositions, and that's the real important part is what goes into the blue boxes as the interfaces between the reds. Does that make sense?
Kathleen's on the queue.
Yes, so this is Kathleen. What I'm wondering is for things such as profiles, are you proposing an IANA registry where you would add these two, or you know, a new body of work? I'm hoping it's the latter.
Yeah, it's a letter. So before we go to any Ayana and say, hey, we want something, I think we have to really find out what we want. So this is I think, an addition to the architecture. I think this is the next architectural step that we have to do, because the RATS architecture is about one RAT. And
Right.
now we
So
have
this
to
is
talk about, yeah.
Yeah, so it's about applied use cases. So it's not unlike the draft that I have. I didn't get an update in time due to a technical glitch, but yeah, okay, good. I'd say bring it to the list so that there can be more discussion too.
Yeah, yeah. This is a floating device here. Okay.
Thank you.
Hi, this is Romain. I'll take my hat off. I'm really confused. We're talking about profiles. I don't know what we're profiling. Is it RATS stuff? Because we're not done most documents, right? So we're now talking about building profiles on what? The 2 published specifications we have?
Yeah, actually, we will have like 4 or 5 in the clusters cleared, and then yes, then the profiling starts. So we are starting the work now, taking into account the stable items that are RFC already, and there's the pretty stable item that are in queue, and then the work that we might have to align with that is quorum at the very, very least, or Kathleen's ID. So your confusion stems from, yeah, we actually only have 2 items that are really RFCs, and that is absolutely correct. What we want to figure out is how different are the contents of the blue boxes from different RAT combining scenarios. Like, for example, the CI build. And the next example, you will see there's another one. And how similar are they? And now we can find more examples, maybe have a list, and go from there. And then when we have all these lists done and these comparisons, I'm pretty confident we have 5 to 6 stable RFCs. And then we do the actual, I want to say, adoption of this work. That's the plan. But we floated very early. There's no ID yet. That is why we are talking about this now. We just wanted to hear and get feedback. Are you shocked that there's not a single RAT in practice? Do you think that this is worthwhile to talk about what RATs move between that other?
So Hank, I
Kathleen,
think
or Nancy, you're trying to jump in?
I am, because I'm being challenged. It keeps booting me out. I've been trying to call time, Roman, when you got up to the queue. So Yogesh, sorry, I'm going to call time right now. Hank, it sounds to me like you're still trying to socialize and scratch at what it is that you want to present more concisely. So my suggestion is to absolutely take it to the list. Solicit contributors. You could have a side meeting. You could ask for an interim session.
Yes.
If you want deeper, right?
Interim sounds great. But we need documents for that.
Exactly. So I think you need a little bit more work, but you can at least start socializing some of this, as I said, inside discussions or on the mail list.
Thank you.
All right. So thank you for that. I'm going to call time.
Okay, next up then is HSM evidence. Mike. Save it for the interim.
Hank is tall. I am less tall. Okay, I'll try and go fast. This should give some time back to the agenda. This is just basically an update on the design team. We have nothing new. We have no new version of the draft. So this is just a status update on our bi-weekly design team meetings. Next, please. So since Prague, the design team has continued to meet twice a month on Mondays. If any of you would like to join the design team, send me or Hannes an email. The main focus of our design team has been getting the LAMPS draft CSR attestation to completion, which is getting very, very close. And then, so the typical flow of the meetings is we spend 40 minutes looking at GitHub issues for the LAMPS work, and then 10 minutes actually working on the RATS part. So it's been moving pretty slowly. But we have made progress, not tangible, as in none of it has made it into an ID text update yet, but we still have, I think, made good progress on aligning the group goals. Yeah, so I've put a link to the meeting notes, which I take careful notes after each meeting. So if you want to catch up on what's been discussed, they're all there. Next, please. So I just want to clarify, I was asked by some of the participants of the group to give a little talk here explaining what the goals of this work is, because I think it is a little bit different than what this working group typically deals with. So this is a design team composed mainly of HSM vendors. And by HSM, I mean a 19-inch rack-mounted thing connected to the world by an Ethernet cable. I'm not talking about chips soldered to motherboards. I'm not talking about USB devices. I'm talking about big HSMs. Next, please. And so the architecture of these devices, and there's several, a half dozen or more vendors in the market that make these types of devices, and they all have different architectures. So this is a gross overgeneralization. But the architectures of these devices tend to be that the rack-mounted appliance has some vendor firmware in it. Let's call it a crypto kernel that owns all the cryptographic keys. Typically, all of these devices have some way to load third-party firmware onto the HSM, so running inside the hardware boundary. And then that interacts with the world through an Ethernet port. And so you may have software applications that are making use of the keys on this TPM, either directly to the vendor kernel or through a third-party firmware kernel. Yeah, so this is, I think, a little bit different. And so why we're having to do a totally new design project here, I think, is motivated by the fact that this is a bit of a different problem. So the example here I want to illustrate to make this picture make sense. Imagine this HSM is part of a credit card manufacturing environment, and it's holding keys owned by a bank, certified by Visa or MasterCard for printing cards. So then in that case, the third-party firmware running inside the HSM might come from the credit card manufacturer stack provider. And so the third-party firmware might be, for example, hardening PKCS 11 to match card production standards, or it might be encoding public keys and private keys so that they can be loaded onto the chip in some financial services specific key format. So it might, modifying the base sort of P11 to do whatever sort of application specific thing is needed. The other thing that's sort of weird here is if you need to certify any of these keys, if there's any keys in an HSM that need to be certified, the CSRs for that would typically be constructed on the laptop, then sent back into the HSM to be signed. So there's some sort of weird non-trivial interaction of where the data is created versus where the data is signed. And there's at least 3 sort of layers of boundaries that you might consider as environments you might need to create attestations for. So this is a composite device in a bit of a weird, different way. Next, please. So I think the rough design goal that the team has been working through is sort of confusionified by this Venn diagram in that, we've got a number of big HSM vendors participating, and their devices all work quite differently, and their functionality sets are all quite different. And we're also trying to, at the same time, say, all right, we've got Talos and Utamako and Enshield and IBM and Crypto4A, and can we define what is the intersection of functionality between those devices, and then overlay on top of that TPM, and can we find a reasonable middle ground or a superset of the middle ground that represents all that functionality? So PKCS 11, anything that's P11 is considered to be common functionality. Obviously, there are keys in all of this. All of these things can describe whether they're in FIPS mode or not. And then there's things like we'll need some form of submodules claim to describe any sort of third-party non-OEM software that's running inside the device. We need a unique way to define the device, and I've put their OEM ID, hardware model, hardware versions, hardware serial outside the TPM boundary, because I understand TPMs actually don't want a unique identifier for the device. Is that right, Monty? For privacy reasons? Depends on the application, yeah. So there may or may not be a hardware serial depending on the privacy designs of the thing. But for big HSMs, I really do want to say this firmware signing key is on HSM4 in the data center in Switzerland. And that's super important that it's not in a data center in the US. And so I actually do need to tell which physical hardware this key came from. So this is something that's very important for HSMs, but may actually be an anti-goal for other types of secure processors. HSMs also need to be able to describe the backup and restore state of a key. So I could say, tell me about this key, tell me how many times it's been backed up, tell me if it's ever been restored, tell me, again, things that don't come up in a TPM world. So next, please. So the design goal of the team is basically, can we describe what's in this intersection, and can we come up with a standard evidence format that will describe this stuff in a vendor neutral way? And it's turning out to be quite the adventure to get consensus on this. And I'll also note, we want to do it in an ASN1 native way. So I'm very sorry. That was explicitly stated at the beginning. All of the HSM vendors are ASN1 shops. They want to be ASN1. This has got to go to a certificate authority, which is an ASN1 shop. We're doing this in ASN1, not up for debate. Next, please. It's not. So things that we do have rough consensus on, and this is hot off the press as of like our design team meeting last week. I'm not even sure all design team members will agree on this, but here's my view of what I think we have consensus on. We would like to define a list of claims, all of which are optional, including subject key. So it may or may not be a key attestation. You may, for example, need to verify the running state of the HSM through an attestation prior to actually generating any key material. So, or you may want to ask about the running state of the HSM independently of any key material. So subject key has to be an optional claim. We have to support, so if you want to think of it as platform attestations and key attestations as separate objects or potentially nested. We want the format to be extensible so that we can add more claims later outside of the RFC, and potentially even proprietary claims. Vendors can just start tacking on their own proprietary stuff, and that'll be handled gracefully. The general protocol flow we want is that the caller, which is typically going to be like a laptop or another server running outside the hardware boundary, can construct the set of claims that it wants filled in. So you essentially construct an empty form, the list of keys with empty values, and you pass that into the hardware, and it will collect the evidence and fill it in and sign it. So that basically means we want all of these claims to be optional. You can pick and choose which ones you want and say, here, please, go fetch. Yeah, and as I said, all the key stuff needs to be optional. So we're making good progress on the list of claims. We've got this running in the meeting notes. We've got this running list of claims that's growing. I think we'll probably need to prune it down a bit. It's probably gotten a bit unwieldy, but we're making progress at building out what we think is a base set of claims here. Next, please. Things that we have non-consensus on is, should the carrier format be an X509 certificate, or should the carrier format be some new ASN1 structure? So the X509 idea is basically when you request a key attestation, then you produce a normal X509 cert. When you're asking for a platform attestation, you produce an attribute cert, and all of the claims go in V3 extensions. It's straightforward. It's commonly done. We have good tooling for working with X509 certs, so there's good reasons to do it that way. The other half of the design team wants to define a new ASN1 structure, which is basically a sequence of claim with a signature field at the end. And that the advocates, the proponents of that, are saying that it gives us more flexibility in how we design this. We're not stuck with all those sort of legacy vestigial organs of X509. We can add multiple subject keys and multiple signature fields to ease PQ migration, et cetera, et cetera. We can actually make it do what we want in a more flexible way. So this is I think, the big thing that we need to get the group to consensus on before we can actually write down a concrete proposal.
So Mike, you're going to need to wrap up quickly.
Sure. I think I'm...
Just time check. Yeah, I think you have one more slide.
Yeah. And it says summary at the top, so that's good. Yeah, so summary is trying to get 4 HSM vendors and the TCG TPM people to all agree on what is common functionality has been fun. We're progressing well. We almost have the design requirements nailed down, and I think once the design requirements are solid, the actual content should follow pretty quickly. So that's just a status update. No new drafts. Thank you.
Thanks. All right. We're eating up into the open mix, so let's just move on to the next one.
Hi, I'm just checking because I proposed the updated slides, so I'm not sure this one's the latest.
I think they are the latest.
It's okay.
Well, so Ned, I literally just approved them like 10 minutes ago.
Yes, cool. Thank you. Thank you, Rats. Thank you, chairs, for giving us time. Yeah.
I'm going to flip forward and see if those are the right ones.
Yes.
Oh, no, tell me.
No, this is not the latest.
That's not it?
Yeah, I mean, it takes a while for it to refresh, so you're not going to get the latest.
There's a refresh documents button. Let's try it again.
Can you go? So that's not the latest one in the data tracker.
Yeah, I don't know if I can get it. Yeah, let me see if I can find it.
Just tell us about your stuff while you wait.
Yeah, kind of introduce it, and we'll see if we can find it.
Yeah, thank you for introducing, giving us time to introducing our new initiative. This is a initiative that's is a cross area between the routing area and the security area, and it was discussed in the secure dispatch, and it was directed to the routing area. But the reason why that we are taking up Rats people's time that and maybe interests you is that there's two reasons. The number one is that we use Rats as dependencies. We kind of consume the results of the Rats outputs, and in order to achieve the routing security. And number two is that we're from the name, and then we can see that it's a very similar concept. So there will be like reference designs that are similar to each other. Right. So now it's like, I don't know.
I think I got them. Give me a second.
Yep. So I can just talk ahead. So basically, when we have the previous routing, like maybe 20 years ago, like we have a basic assumption is that the router is not trustworthy. It's doing the best it can. So this does not promise any kind of predictability of forwarding behaviors. And but now things have changed a little bit because we have Rats. We can establish trust on a single device of some sort. And now we can have sort of controls or predictability of a single network device. So with a trusted device, with trusted operating environments, with trusted links, there's no reason that we cannot connect them to each other to form a network path, a trusted network path. I'll just use this. Thank you. Yes. And for right now, our goal is that we want to protect data security by we orchestrate a path that consists only of trusted devices, trusted operation environments, trusted configurations, trusted links. You only use that trusted single point of trust, and then we connect them and makes a trusted path, because the previous routing security does not permit adding of that. Next slide, please. In here that we have some discussion in here that we actually have this initiative with a lot of operators in here, and the routing area directors, they are kind enough to sponsor the creation of a mailing list to continue this discussion. And now we have, right now it's like a draft charter, the draft architecture that we have to, decent enough to have a site meeting the Wednesday and ultimately seek the formation of a working group. And right now, like we have basically 3 steps to attest to a path is that what we know what we are testing to, like path level trustworthiness claims or attributes. And then we know how to attest is that when we consume the attestation results or trustworthiness proofs from Rats, then we can consume like using a dedicated packet that goes, traverse the path and consumes each individual device's attestation results, and then we can produce like a path level attestation result. And the number, the third step after the construction of this path, we can have like an in-band or out-of-band verification, like proof of transit, to make sure that the data still goes on top of this line. And next slide, please. Here, the graphical is there's 3 steps. Basically, we can have like a centralized controller, or we can have like a decentralized way. We can use Young model to collect what are the devices that we have. Sorry, this is not the latest. Imagine there's like a controller on top of it. We can use like a Young model to collect what are the devices. Maybe some of them are remote tested, some of them are not. But consider like the operator clients, they want to have some kind of a secure lease line. They are very security sensitive clients. Maybe they're from financial institutions, they're from governments. They want their forwarding behaviors to be predictable. They want their forwarding only on top of trusted lines or trusted devices. And now the first step is for the operators to know like what are the trust levels, or what are the trust conditions, security conditions of these devices. So the first step will be having like a Young model, or we can use some BGP LS methods to collect the trustworthiness status of the existing devices. And next step, next slide. And then we can have this kind of dedicated packet that traverses this, this path that may be orchestrated by using segment routing, or any kind of explicit routing, or just any kind of regular traditional routing. And then we can have this dedicated packet that goes to traverse this path, and then consumes the individual attestation results that both secures the hardware and the software and the configuration and everything, and the link, the trusted links. And then finally, next slide, please, is next slide is like animation. Next slide. And then this will produce this is like a final path level attestation result that's more or less coincidental to what Hank mentioned. This is like the way that we connect things to each other. And then we send this to clients for auditing or verification. Could be clients, could be auditing parties. Next slide, please. And yes, after the construction of this trusted path, like when we're actually using this path, we can use some proof of transit methods that could be like in-band checks that goes with a packet hop-by-hop checking, or we can use some telemetry checks that goes using management plane protocol extensions to collect, okay, now we have this trusted path. Are my packets strictly going through this path? It's not deviating from this path. And then that's the third step, to verify. And then these are 3 steps that we're trying to charter this working group, and we have proposed standards or informational status intent in the RFCs, and that's basically it. And next slide, please. In RAT's language, here the attesters will be the devices, and the relying party will be the client or the operator or auditing parties that's interested in the trustworthiness of this network path. Next slide, please. I see I see people on the line. Please go ahead, Yogesh.
Yeah, I just wanted to ask, have you already looked at the RAT's trustworthy path routing, and how, if you have, then how different is that work and this work?
That is very correct. So that's one of the inspirations that comes to us, and I think we will, if we're gonna have like a working group level initiative, that we will have this kind of architecture to be designed, and then it could be like referencing the designs from the TPR draft. Is very inspiring, and I don't know if Eric is on the site or he's online, but we will be referencing designs from that. That's a great draft.
Thank you.
So Eric is not on the call, so my suggestion is to reach out to him. Roy, you're going to have to keep it short because I'm going to have to call time, and I'm going to close the queue.
Sure, no problem. Roy Williams. Question is, what do you think this does for things like email, where it goes through MX records and multi-hops? Are you going to try and say that you're going to pop it up into the SMTP data trail to know how it routed from one end to the other? Or is that out of scope? Because if you're trying to solve a real world problem, then email seems to be a large part of trusted flow.
Okay, I don't know if I get the question correctly.
Well, email is built into DNS, and MX records say, hey, if you can't hit point one, back off to multi-hops along the way, which then makes this problem much more harder to capture and retrieve the data to say that you made it over successful constrained networks.
Well, I'll have to think about that and come back to you later. Yeah,
sure.
Sorry. Also, time is kind
Thanks,
of
Nancy.
limited. Yep. And next slide, please. And yeah, this is the last one, I promise. So here, we're here for guidance and collaboration because number one, we have dependencies from RATs. And number two is that we want some referencing designs, maybe from TPR, maybe from other technical know-hows that are, because we have similar logic, we have similar interactive procedures. That's why we're coming from RATs for guidance and comments. And we're also looking for collaboration. We'll be actively designing the architecture and the main protocol and everything. And then we're also looking for active buff co-proponents. Right now, we have a few operators, and we're also happy to expand. And this IETF, we are having a site meeting. You can find it on the page. You can find it on the slides. It's on the Wednesday evening, 6:30 to 8. It's a 1.5 hour. And it has a packed agenda. Also, in the next IETF, we plan to have a non-working conforming BOF. And after that is a working conforming BOF. And we will have interims and design team meetings in between. And the agenda and materials are uploaded for your convenience. And then we have a wiki page. And also we have a mailing list sponsored by the routing area directors, kind enough to do that. And that's basically it.
Okay, I am going to have to call time. My apologies. So thank you for that. RATS participants, you know there's a side meeting. There's a mail list also. But yes. I also suggest, Peter, that you look at the trusted path routing draft, because a lot of the things that you mentioned is covered in that draft as well. Okay, so with that, let's move on since we're running short on time. Thomas, if I can keep you straight to 9 minutes, because I think somebody wanted something on the open mic.
Okay, thanks, Nancy. I will try to keep this as quick as possible. Next, please.
Thanks.
So it defines a measurements claim, which contains descriptions for evidence of the software or other measurable subsystems that exist within an entity. And currently, COSWID is the only format that is supported, but its measurements are extensible. Yes, we tried with COSWID, but we didn't find it a very good fit for environments that, like early boot, where you don't have a file system onto which you can anchor your measurements. Next, please. So we defined our own thing, which is the PSA software components, which is a claim that we define in the PSA profile for it that basically does without a file system object and basically creates a compound claim that described a digest alongside some metadata, including the name and version of the software components and other information like who's the guy that signed the update. Next, please. So we have some experience with that. We have gained some experience in the meantime, and we think it's worth possibly putting this forward for to the general audience. So we started off trying to refactor that software component that is PSA specific into something that is more generally usable, taking into account the recommendations for new claim design that are contained in its Appendix E. So in particular, look at interoperability, the relying party orientation, the reuse of extant data formats as much as possible, and in general neutrality towards security and operating systems and technology. Next, please. And yeah, we started with the info model, right? So we stepped back a bit and defined the info model where we describe the information elements that we want to use within this claim, this compound claim, with a clear description and requirements level. And these are those, right? Component name, component version, digest value, which is the core thing, digest algorithm, the signer and countersigners. And we think this is pretty much what we want to have. Next, please. Except maybe there's something else that people might want. For example, SVNs. We were asked to look at this as well, but we are open to any comments on this. Next, please, to make so that the information model is covers as many use cases as possible. And so in this draft, which is a 0.0, well, it was a 0.0 because in the meantime we updated a bit. So it's 0.1 at this point in time. I think we define a serialization for a measured component that is CBOR and JSON. And is, as you see here, so the measure component has an identifier, component ID, which defines basically name and version, meta information about the object that is measured. It has the measurement itself, which reuses the quorum digest, and therefore a compound object that pulls together the digest algorithm and the digest value itself, and then signer and countersigner as cozy key thumbprints. Next, please. And then we went through the exercise of extending the measurements claim in it, which was pretty interesting because we uncovered probably a few missing bits in the IT spec that we've discussed with Carl and Lawrence already. But this is the CDDL that you need in order to fulfill the requirements in the IT spec. And so this is it's been pretty useful as an exercise, and this experience can be, I think, brought back into the EAT specification. But basically, you need to define the way you encode your claim, your new measurements claim into both CBOR and JSON, natively and in a tunneled way, right? So when you are sampling in CBOR and then you're collecting in JSON and vice versa. So you need to have all these things in place. On top of that, you also need to make a registration for the media type of this object and the relative content format in order to fulfill the measurements claim requirements. So this was pretty good as an exercise, I think. Next, please.
Ned has a hand up.
Oh, yes, sorry, Ned. Go ahead.
Yeah, or on slide 6 or 7, you mentioned component ID. Was that from any of the existing, like COSWID, RFC, or that was something introduced from PSA token?
No, that is new, but inside that there's bits from COSWID. There's the version, software name and version from COSWID, I think. So if you look into the draft, you should see that, but it's not evident here. Sorry. It's okay. But inside that component ID there are reused bits from the COSWID spec. So
it is in some way connected to COSWID.
Yeah,
representation of a thing.
It is, but only, just small bits. It's not taking the whole COSWID. It's just primitive types. And the relation with other drafts, so Mike was mentioning before, he was talking about the X509 based attestation evidence draft that they have. And I think initially they were suggesting to reuse the PSA software components. So maybe they could look at the info model to see whether that is a sufficient basis to construct a one serialization. So I will, I would like to hear from Mike about that. And we think this is generally reusable. In any case, even outside the EAT spec and the specific of the measurements claim. Hi, Mike.
Sorry, the question is.
Make it quick because we're at time.
Yeah. The question is, should we reuse the EAT claims in the X509 base? Like, should we just take EAT and run with it? Is that the question?
No. The question is whether you want to reuse the info model that is defined within this draft to model your software measurements.
EAT's not ASN1?
No.
The semantics. Yeah. So if you look in our meeting notes, we started with the EAT semantics. We took all the EAT claims and their semantics copied directly, and then we've been adding to it, but we haven't changed any of the stuff we borrowed.
Right. This is an extension to it that allows you to define those things in a more rich way. So maybe you want to have a look at this, but okay. I will talk to you. Yeah, no problem. Next, please.
Can you wrap up, Thomas?
Yeah, I will. Yeah, that's it. We think this is useful. We have implementation experience with this, and we think it's a valuable addition to the EAT bag. So, question is whether the group wants to adopt this.
Well, so I think we're at time. So what we can do is we can ask on the mail list who's read the draft and to see if there's any interest.
Fantastic.
So
Thank you,
we'll
Nancy.
take it to the mail list.
Awesome. Cheers.
Thanks.
Thank you.
Okay.
Okay, thanks, Nancy. So we're into open mic time. There was a request earlier for an open mic topic, and I think Hank is going up to the mic for that.
Hi, this is Hank. Am I using this mic?
It's up to you. That one you
Okay,
got to eat that mic though.
Okay. So this is a small. So thanks. So this is a small update on the RATS endorsement ID that has been adopted by the working group. It's pretty much in its final stage. Lawrence just in time, so to speak, indicated that endorsing identity is basically about key material for remote attestation, and so that section is under churn right now. That is just happened recently. I think we have to address that valuable, and I think the authors and editors agree, viable inputs, and then read the whole thing for consistency. And I think working group last call is then the next step. So Dave can't be here because he's in a other session right now, and that's why I'm basically reporting on that, and that's it.
Okay, thank you.
Thanks, Hank. We'll have to make sure we get reviewers, by the way. Okay. Well, that was good. We have 1 minute left. Is there any other business? Going once? Going twice? Okay. I think we are done for today. So the notes I took is we're going to do a pulse to see who's read the EAT measurement component. Hank, you're going to do the discussion for your future work. I don't remember the title of it. And then the other documents continue to mature.
We talked about doing an interim meeting for the topic that Hank had.
Okay. I took it as Hank had to mature his idea and maybe have a draft before we do an interim.
Okay.
Okay. So I think with that, I mean, Ned, you've got a better view of the room. I just see 5 people. Any other comments, questions? Otherwise, we can call it.
Looks like everybody's anxious to get out of here.
All right.
Thank you.
With that, thank you, everyone.
Start the day with 2 editorial requests for signed documents.
Okay.
So you're actually here in person.
I'm here in person.
Hey,
Yes.
nice to see you.
Yeah.
Well, thank you for attending remotely then, I guess, from one room to another.
Yeah.
Where did you hear about Kerry?
Um,
How did that come up?
that's work my brother's doing.
Your brother? Oh, Sam Smith is your brother?
Yeah.
Oh my goodness. That is fascinating. I did not realize that Sam was, Ned's brother. Yeah. I met with him and I discussed stuff. And we approached the problem right because I don't think Kerry sold from Sam said so. Because they still assume that I think there was a seed, maybe it's more different. There's an initial